Okay, so today we're going to do some drawing. We're going to go a little bit more into why some of these things in perspective work the way that they do. The tools that I'm using today, these are all HB pencils. I just happen to have 3 different brands of HB pencils. I've got them sharpened and ready to go. Working with dull pencils in perspective is problematic. Your lines get a little too thick sometimes. And also, when you're drawing a line with a straight edge, which we do a lot of, if your pencil's fat and thick, it doesn't draw right next to the ruler. It gets pushed away a little bit and your lines don't exactly line up. So precision's really important. So I always try to keep some sharp pencils handy. And HB pencils keep their point longer because they're harder lead, right? So that's why we're using HB. Okay. When we're setting up a perspective drawing, what's the first thing that we always need to be aware of? It's the first thing I'm going to put down on my page. It is good. Did I see the pencil sharpener? Sorry. Did you say horizon line? If you did, you were right. Congratulations. If you didn't know that, learn it, because we always need to know where our eyes are at. What's below us, what's above us, what's to our side, right? And for precision, I'm going to put it 2 inches down from the top of my page. So I'm measuring down 2 inches because I want to be precise as I can. Your horizon line should be horizontal. Okay. And what I'm going to do is I'm going to draw my horizon line clear off my page. And you'll see why I do that here in a minute. But that's why we have this extra sheet of paper so that my horizon line can go past, right? Okay, so, and then for the first little bit, I want you guys to label these so that they're not just random lines on a page. I want you to know what they are. They represent something, right? They mean something. So this horizon line means a few different things. What does it mean? Say it nice and loud. It's where your eye level is. Okay, it means other things too. What else does it mean? We'll call it our eye level. I'll even put a little EL here. But in 1 point perspective, your eye level is also, what's the other name for it? Starts with an H, horizon line. When we're doing 1 point perspective, the eye level and the horizon are the same, right? And so what that means is what's above the horizon? Sky. What's below the horizon? Earth, okay? So it means those things. It's not just a random line. It has meaning, right? So you could also put horizon line. The next thing I need to know, so I really wish I had like a G.I. Joe figure or a troll doll so I could put him in here. But if my pencil was a person and he was in this world, his eyes would be right here on the horizon line, right? Something like that, okay? But we also need to know where this person is from the right or the left, right? And so I'm going to put my person right in the middle of my page, okay? So this is a 9-inch sheet of paper. So if I put a mark at 4.5 at the top and at the bottom, then I can connect those lines. And I'm going to draw this line lighter, okay? And the reason why is my horizon line actually exists in the world, right? You see a horizon. The line of sight is kind of a symbolic line. It means this is where I'm standing. So if I have an object, like a cube, if it's right in front of my face, I don't see the bottom, the top, or the sides, right? But as I lower it down into this world, I start seeing the top and the front, right? Or if I go above my eye level, I start seeing the bottom of it. And as objects move to your right and lower, you start to see the side, right? And the top. Does that make sense to everybody? But this is what determines that. It determines our relationship or our perspective, where we're viewing the world, okay? And so I'm gonna label, I've got my eye level, and I'm gonna use abbreviations, but LOS, zoom in on that. I have my line of sight, I have my eye level, and where they intersect in 1-point perspective is also an important thing to be aware of, which is the vanishing point. And I'm gonna put a little VP here to remind me that's my vanishing point. It may seem really basic, but it's actually super important, okay? So the other variable that exists when we're trying to create a world, right? It's just dirt on paper, but we're trying to create a 3-dimensional space, like walking into a Minecraft or something, right? The variable that we don't have right now is how far away we are from this world. We could be really, really close, like this, or we might be really, really far away, right? And what determines that is what we call our station point. And you can't really draw the station point because the station point is on the z-axis, right? It sticks out of the page. But we can take it, like if it was a ruler, if it was the distance, if my face was as far away as the point of the pencil from the paper, what we can do for perspective is we can actually drop it down onto the page, and we can represent it on the page by putting it below the eye level. Does that make sense? And for this drawing, we want to move the station point pretty far away. Why do we care about this? This is probably something none of you learned before this class, am I right? Did any of you guys ever learn about station points before? Why does it matter how far or close we are? Do you remember that demo we did last time? What changes? The measuring line does change, for sure. But there's another reason why it's important. We call it the cone of vision. Does that make sense? If you're really close up on something, like it's right in front of your face, it gets really distorted, right? We took a picture of someone's face close and far away, and it looks weird, right? So the further back you go, the more you can see clearly, okay? And so if we put our station point really close, we're not gonna be able to draw very much. So we wanna move it back as far as we can. Does that make sense? And we wanna control that in our drawings, okay? And I didn't draw this in first period because I was trying to simplify, but the reality is, you don't need to draw this, okay? Just watch. This is a 30-degree corner, and a human's cone of vision is about 60 degrees. So very lightly, I'm just gonna draw a light line here. I don't want you to get confused by this line because we're not measuring anything with this line. It's just a guide. And I hit a bump there. Let's try this again. It's just a guide to say anything in this 60 degrees here, and I'm gonna call it the COV, is gonna be normal. Anything outside of that is gonna look weird. It's just gonna start, because we see what's in front of our face. What's over here is out of focus, and when we turn our cone of vision, right? And so everything looks normal, but you only really see what's right out here in front of you, about 60 degrees. Okay, that's the cone of vision. And you're like, you already explained this 15 times, but hopefully every time it just makes a little bit more sense, okay? So it's 30 plus 30. I do 30 on this side, and then I do 30 on that side. Let me zoom in. Great question. So together, your cone of vision is 60 degrees. Does that make sense? Okay. And because I backed off so far, what that allows us to do is have a lot of area inside our cone of vision to draw today. Does that make sense? Anything we draw inside of this area is going to look really good. Okay. What you guys need to draw is what we call our measuring point. And I'm going to explain this one more time. You might already have gotten it from last time. But if you take a square and you have it right at your eye level. So imagine this top plane's a square, right? As you lower it down, it starts to get bigger and bigger and bigger, right? The further away you get. What happens theoretically is when it hits the station point is when it actually becomes a perfect square. Does that make sense? And from the station point, whatever's a 90-degree angle will go right to the vanishing point. So in this world, anything moving straight away from us goes here, right? And that's because that's where it goes when it's at the station point. See how that line lines up perfectly with that line that goes to the vanishing point? Okay, so the other logic, I'm going to flip my page up. Don't draw, just watch for just a minute. Okay? So there's just logic with squares. I'm just tracing my square here to put a square on the page. And what's cool about perspective is that the logic that works when it's not in perspective, so this is just an actual square, right? It's geometric square. It's not in space. And if you have a perfect square and you want to find the middle, you can connect corner to corner. That's actually true, by the way, for rectangles as well. If you have a perfect rectangle, you can find the center of a rectangle the same way. And so what we're learning about with squares can actually apply later to rectangles as well. But what's interesting about this is now I know the center of my square. And so if I follow the rules of perspective, so for example, vertical lines stay vertical, right? So if I draw a vertical line using my right angle here to make sure it's straight, I can use the center of this square to find the center on the edges, right? And I could measure it and it would be perfect, but I can find the center without measuring. Does that make sense? And you can do it the same way this way too. And again, when you're in a perfect like square, this might not make a whole lot of sense why that matters, right? Because you could just literally measure that's 1 inch, that's 1 inch, and you could find the middle. But it's not so easy when we're dealing with squares in perspective, okay? But there's a lot of information that I can take from knowing this, okay? So one example, say I wanted to make another square right next door, and I want to make it exactly the same as this square. I have enough information here already that I can make a perfect replica of this square without measuring anything. So one thing, for example, and this is important. I have a back corner right there. And because I took some time and I figured out where the center is, I have a corner right here. And using these two corners, here's a little perspective trick that somebody figured out. If I go from that corner to that corner, and I'm trying to take my time and make sure I get this perfect, but I'm going to draw lightly. Where I strike through that gives me that exact length again. I just found an exact square just past. Does that make sense? And we can use that, you'll see in just a minute. And then I can use my logic, right? So I can bring down a perfectly vertical line. And there's my next square. So imagine this is a sidewalk, right? That keeps going on and on forever. That's what we're going to do today. Now I got this square. Again, I can find my middle. I could draw another line through and I could draw the next square. And then I could draw the next square and the next square forever, right? Okay, so that idea is going to come into play in what we're doing today. Okay. So The other way that we can do the same thing is use a measuring point. So down here at the station point, all 90 degrees go here. But when you have this line here, when I go from this corner to this corner, so from the front edge to the back edge, what degrees is that?
45.
It's 45, right? It's half of 90. So if I didn't know where this line was, I could figure out where it was by going to 90 degrees. Does that make sense? So for example, let's just do this real quick. I know maybe this is super obvious, but we're going to be super obvious here for a minute. So if I don't know where the back of my square is, another type of logic that I could use to figure out where this next square is simply use my 45 degrees. So if I go, oh, that's not 45. This is the one with 45 degrees, the one that's like a pyramid, okay? But if I put a 45-degree angle from the top corner to the bottom, that also gives me a perfect square. Does that make sense? Allie, did you need something? Okay, so that also is a way I could find a perfect square. Does that make sense? That logic, okay? So when we go on here, if we know where the vanishing point is for perfect 45 degrees, we can also use that to find the back edge, okay? So if I take this triangle right here and I grab a 45-degree edge, and you guys have a 45-degree angle. Does someone close by have a small one? Let me show you how I use a small one. I have a few big ones too, but even my big one doesn't quite reach where I need it to reach. But if I get my triangle placed about where I want it, so that it's pointing right at my station point, I can just take my ruler and extend it. And where the 45-degree line hits the eye level, I'm going to call this my MP, my measuring point. It's a 45-degree vanishing point. So if I have my square in this world, this line will always go to the vanishing point, but this line will always go to the measuring point, or the 45-degree vanishing point. Does that make sense? Okay, so but I call it a measuring point because I'm never going to draw actual lines in my drawing to that line unless I have a 45-degree angle, but I'm going to use it to measure. So that's why I call it a measuring point. So you'll see in a minute how that works. Can you guys see this okay? I could try to draw with a 2B or something to make it a little darker. But so far, the things that you should have on your paper: you should have an eye level, you should have a line of sight, you should have a vanishing point, you should have a station point, and you should have a measuring point. If you want to have the cone of vision, you can, but don't get confused because this and this are not the same thing. And in our drawing, every line's, this isn't for measuring anything. This is just to tell us to stay inside it. Does that make sense? Okay. All right. So what I'm going to do, yes. You want your tools back? You got to watch out for me, guys. I don't do it on purpose, but I steal tools. I steal pencils and walk away. Sometimes I'll leave a pencil. But don't let me steal your stuff. Okay. So what we're going to do, we'll do it a couple times so that we can practice, but we're going to make a couple sidewalks. I'm going to pretend like there's a road down the middle of my page, and I'm going to put a sidewalk on either side. We're just going to do it one at a time, but we have enough space to do a couple sidewalks. And all I'm going to do, I'm going to do this really arbitrarily. I'm just going to say, here is one edge of my sidewalk, and I'm going to come over and I'm going to draw another sidewalk, or another part of my sidewalk right there. So this is a sidewalk moving away. We could walk down that sidewalk. Does that make sense? Do you see that? Can you envision that? It's just a sidewalk.
20 CE drawing, CE 1030 studio art, sculpture 1, sculpture 2, independent studio art, AP 2D design and drawing, commercial art 1, graphic designer.
Commercial art 1 should be removed from the list.
Okay.
So should commercial art 2. It should only say digital art. And I've been talking with them all morning trying to get them to
Digital
fix
art.
it. It's
Is
called
not a CE
it's
class?
called digital illustration, and it's a CTE class.
Digital illustration. I'll put CTE in parentheses so they know.
So, and if you look right out here, actually,
So it's not.
let me show you. Sorry guys. Do you guys all have a sidewalk drawn on there? Everybody draw a sidewalk. Doesn't matter. You could draw it right down the middle if you wanted. I left room so I could draw another one over here if I need to demo again. And I'll show you a couple different ways that we can draw it. But everyone should have a sidewalk, yeah? Who doesn't have a sidewalk yet? You could put it anywhere in that world. What matters is in 1 point perspective, it's got to go to the vanishing point, right? So whether it's twisted this way or that way, doesn't really matter. If you try to go out really far sideways, it's going to look weird. Just because 1 point perspective isn't really designed for stuff that's clear out this way, but it'll still work. But you should just have a little imaginary road that leads to the vanishing point, okay? Does anybody need me to wait? I really don't want to rush ahead of anybody. Can we continue? Okay, so rules of 1 point perspective. We've been over this, but just real quick. There's 3 places where lines can go. We have vertical lines. In 1 point perspective, where do vertical lines go? They just stay vertical, right? So any lines that go straight up in the air, whether they're here, or these back two that are hiding, these would still be vertical, right? And so you would draw vertical lines vertical, okay? If you follow this logic, it's gonna make sense. I had kids whose sidewalks started to tip, like it felt like a rope bridge that was swinging, and it's because they broke this next rule. Horizontal lines have to stay horizontal, okay? So the cracks in the sidewalk that we're gonna be adding have to stay horizontal, right? Because they're just moving away from us, but they're still horizontal lines. They stay horizontal. Does that make sense? It's hard because you could imagine this as like an ice cream cone and you want to split the ice cream home in half and have it go against the center line perpendicular, but it's not. They have to stay horizontal. Hopefully that didn't make it worse. So for example, okay, and then the other one, right? The lines that are moving away from us, we call those orthogonal or orthogonal. Orthogonal lines go to the VP, okay? That's it. For what's gonna stay and be a part of this sidewalk drawing, every line is gonna be one of those 3 lines and that's it. If you have a line that's not vertical or horizontal and it doesn't go to the vanishing point, it's wrong. Okay? So what I'm gonna do and what I want you guys to do is somewhere not quite up here and not quite out here, just somewhere in the middle, we're gonna draw our first line in the sidewalk. And it has to be horizontal. Okay? And I'm just gonna draw it. And I'm using my triangle. Your triangle will work really good against your line of sight. So if you have a smaller triangle, mine's too big, so I put mine on the edge of my page. But these right angle triangles are really nice for keeping your lines horizontal or vertical, right? Because they already have this 90-degree edge. So if I line this side up and it's straight up and down, this line has to be horizontal, right? And I could use this line, except on mine I have a clipboard and my clip keeps getting in the way, so I have to back up. But if I had a small triangle, I could put it right there. Does that make sense? But this line has to be horizontal. I want to say it like 15 times to just nail it in your heads. Okay? So the challenge that we have, if we have this section right here, and we want to turn this into squares, right? Like the sidewalks going backwards into space. How do I figure out where the lines are going to be, right? So if I zoom in here, I'm guessing, could it be right there? I don't know. I could guess, and if I really liked that guess, I could use logic to make them all that size. So there's a few ways you can do this. So I don't want to confuse you. I'm going to show you one way, but there's one way at a time, okay? And you can try both and see which one you like best. Let's do that. So the first way that we can figure out where the back of this square is by using our measuring point. Because we know if you go from the front corner at 45 degrees, you're going to hit the back corner of the square, right? And in this world, based on where our station point is, our back corner or our 90-degree lines are always going to come to this point. And so I can take a straight edge. I'll just use my ruler. But I can put it on my measuring point. I can hit the front corner. And this line is not a part of the drawing. It's a measuring line. And so I'm going to draw it really light. Okay, but I'm going to zoom in so you can see. But where this line hits, this line, that's a 45-degree line in perspective hitting the back of the square. And I just found where the back of my square is. Right? Does that make sense? Okay, try and see if you can do that. And then once I know where that corner is, what direction is the back square going to go, or the back of the square going to go? I hope you said horizontal. I thought I heard horizontal, but that line, and I drew that line heavy because that is a part of the drawing. This line right here was just a guideline to help me figure that out. And so now I can take my kneaded eraser if I wanted to and lighten that up, if I really wanted to clean this up and make it a nice drawing. Today we're more worried about the logic. Okay, so now I have a new edge. Once you feel like you've got it, just keep going. See how far back you can go and how far forward you can go. And you can jump ahead of me. I'm going to keep talking through and doing this over and over a few times. So if you're not getting it yet, just follow along. But I've got a new corner. And so I'm going to go to my measuring point again. I'm going to hit that corner and very lightly draw a line to the back edge. And now I have the back of the next square. And I'm going to use my triangle here to make sure I get a perfectly horizontal line. I've lined it right up with my line of sight. And I'm going to draw heavily because it's a permanent line. And there's the next one. Yes?
If you do the 45 degree on the other side, can you find the front, like the front angle on the next, like you're going forward?
So the answer is, did you guys hear her question?
Yeah.
So the question is, we know how to go back. How do we go forward? Okay, and she asked if we put a measuring point on this side over here, could we use that to go backwards and forwards? The answer is yes, but you don't need to. Okay, and here's why. So this measuring point, you can actually do on either side. And if I did it, I would have a line going that way. I could actually find that measuring point right now by just going the opposite way. So I could go from this corner back to that corner, and there's my other measuring point right there. It's trippy that this works, but it does, right? And I could put this up on here. Well, mine didn't get it quite right. Don't do that. Don't do what I just did. I just was experimenting. But the reality is we could put a measuring point over here and it would work as well. But we don't need two measuring points. So to answer your question maybe in a better way, Audrey, if we want to find the front edge of this box, we can measure from this corner, right? So I can go from this measuring point to the back corner and bring it up. So I love that you figured out that you could use one on the other side. And if you do it right, and if you're very careful, it'll be exactly the same either way. Bryn, how are you doing? Yeah, you had a look on your face. Did you have a question or?
No, I think I'm doing good.
Okay. Does that make sense though? So again, if I want to go backwards, I've got to figure out from the front corner to the back corner, which goes to the measuring point. So if I really carefully and lightly draw in that line, where that line hits, that becomes where the next one goes. I will fix it. Thank you. And it's going to make me like do the whole enter the code thing. Are we there or no? Okay. So I'm going to zoom in to show you. This line here goes to that measuring point, and then I'm going to use a perfect right angle here to figure out exactly where that touches. And that's my next line back. Okay. Do you want to see it again? Okay. So I have a new block. Here's the front of my square. Okay. So if I go back to this drawing, there's the front corner and the back corner, and they're 45 degrees from each other, right? So I've got my front corner, but I don't know where the back corner is. But I know that all 45 degree lines are going to go to this spot. So I can go to my 45 degree spot over here, my measuring point, and lightly draw a line. And that line I just drew in perspective is this line in reality, right? And so that tells me where the back of my box is going to be. Please ask questions. Okay, and I can keep doing that forever and ever and ever, each time going back to the measuring point, and that's what I want you guys to do. The closer you get to the horizon line, the harder it's going to get because it gets tighter and smaller. But go back as far as you can, as precisely as you can. It's good practice. That line goes to there. And then I got to do a horizontal line. So does that make sense? Can I come around and just check and see how everyone's doing?